Hi, my name is Max and I'm going to present the first part of the presentation about the black box testing. Black box testing is a testing that ignores the internal mechanism of the system or component and focuses solely on the outputs generated in response to selected inputs and execution conditions. Black box testing, also called functional testing and behavioral testing, focuses on determining whether or not a program does what it's supposed to do based on its functional requirements. With black box testing, the software tester does not or should not have access to the source code itself. The tester knows only that information can be input into the black box, and the black box will send something back out. Most organizations have independent testing groups to perform black box testing. These testers are not the developers and are often referred to as the third-party testers. Testers should just be able to understand and specify what the desired output should be for a given input into the program. A black box test takes into account only the input and output of the software without regard to the internal code of the program. And this illustration is a great example of how the black box testing works. How the black box testing attempts to find errors. So there are several categories. First, incorrect or missing functionality. Second, interface errors. Third, errors in data structures used by interfaces. Fourth, behavior or performance errors. And finally, initialization and termination errors. Let's look at an example. This is a box that takes some input and gives some output, and we don't know what the source code of this program. However, we can predict what the output is going to be. Let's assume that the first number is 2 and the second number is 3, and let's add them up, and the result should be 5. So what we can do to test data, we can perform testing for several features such as formatting, interpretation, boundaries, precision, file patterns, and validation. Also, we can check for workflow and behavior, such as prompts, error messages, and memory performance. And finally, interface, structure and elements and operation. Are we using mouse or keyboard or both of them? Let's try to compare 3 different box testing: black, white, and gray. White box testing is testing that takes into account the internal mechanisms of the system or component. Gray box testing is a testing of software application using effective combination of both white box testing and black box testing methods. So this is an illustration that can help us to understand better differences between box testing types. The black box testing only knows about the input and output of the user. The white one only focuses on the source code. And the gray, it's a mix between knowing both of the components. And the second part of the presentation will be performed by Ethan. Thank you.
One of the positive aspects of black box testing is that it is much less biased than other testing methods. In this method, the testers and the designers are able to work independently of each other. The tester does not have to have the same detailed knowledge of every part of the software as the designer would have to have. Black box testing can also be applied to the software at each level of testing. Because the tester does not need to know everything or the actual source code in order to run a successful test, the tester is not required to be proficient in the programming language that is specific to the software that is being tested. If you think about this like cars, in order to fix a car, you need to know how each piece of the car works and interacts with every other piece of the car. As a black box tester, you just need to drive the car, testing the functionality. For example, I could turn the wheel and realize that the car makes a little jump, or I could slam on the brakes and show what actually happens when the brakes are being slammed. This also leads to black box testing being able to reproduce the errors that it finds. Black box testing can also identify the specifications of each function on an individual level and reproduce the problem. This is one of the greater benefits of black box testing. It can be performed by the point of view of the actual user of the software. This differs from many other testing methods as they are more from the point of view of the designer. Though there are many upsides to black box testing, it is not without its faults. In this testing, the tester is generally a third party, and so it could be redundant if the program has already been run by the designer and then passed on to a tester. It is also unlikely to find new problems in greater depth because we're not actually looking at the source code, we're just testing the functionality of the program and what it actually does. Another fault is that even though you do not have to have an extensive knowledge of programming, it can be pretty difficult to be designed without the specifications being clear and concise. It also tends to be time consuming. In fact, testing every possible input stream would be impossible due to time constraints. For example, the thing we did last week with the Roman numerals, we couldn't actually go through each Roman numeral from 1 to 4,000. It would take too long, and so that's one of the downsides of black box testings, and because of this, the results might be overestimated at times. It is not possible on more complicated codings to do black box testing either. Black box testing can provide security to the tester in several different ways. One such way is that it integrates with the existing development strategy. So you can perform this testing through any part of the development stage. You can search for security vulnerabilities during the code development itself or as part of your Q&A process. Another way it provides security is that there's no need for the source code, and this is many times why the tester is a third party, and so they don't have to know what your source code is and can still test the program. It also provides security in that vulnerabilities are searched for in a methodical way, that it is repeatable, and therefore problems are able to be reproduced. Analyzing the test situation can determine whether black box testing is the most effective choice for a test. First, it is important to look at who is actually running the test. If the tester is not familiar with the source code, then black box testing may be the most effective and logical test to run. Black box testing is also effective if the tester wants to test specific functions of the program, but doesn't have a need to go through the entire program. It is also effective as a test performed before other testing because it outlines general issues that can be more closely looked at and understood through additional testing. And here are the citations. Thank you for watching.